Hello, everyone, and welcome to the Biophotonics Discovery Podcast. Whether you're a seasoned researcher, a student just starting out, or you just love a good story about how light is used to solve big problems, this podcast is for you. We're making the discoveries in biophotonics accessible one episode at a time.
Shaping the Future of Optical Imaging, The Importance of Tissue Phantoms by Vivian Krause and colleagues at Vanderbilt University Biophotonics Center. The SPY journal Biophotonics Discovery recently published a comprehensive review of tissue-mimicking optical phantoms by Vanderbilt University researchers Vivian Krause, Alec Walter, Anita Madhavan-Jansen, and Duco Jansen. The review highlights the critical role that tissue-mimicking phantoms play in advancing optical imaging technologies. The study underscores a growing consensus on the need for standardized and rigorously defined phantoms as essential tools in the development, characterization, and calibration of optical imaging and spectroscopy devices. Tissue phantoms mimic the optical properties of human tissues, allowing for reliable tests of how imaging technologies operate under conditions that mimic real bodily interactions. They are particularly valuable in fields like oncology, dermatology, and surgery, where precise imaging is crucial for accurate diagnoses and effective treatment plans. Without these phantoms, it would be challenging to assess various optical imaging modalities like optical coherence tomography or fluorescence imaging, particularly when examining complex phenomena such as light absorption by melanin in skin. The paper delves into the evolution of phantom development over the past 2 decades, propelled by advances in materials science and manufacturing technologies such as 3D printing. It provides a detailed overview of current methodologies for designing phantoms, emphasizing the importance of using geometries and materials that mirror the target tissue's mechanical and optical absorption and scattering properties. For instance, the authors discuss how hydrogels and silicone can be tailored to simulate the elasticity and absorption characteristics of skin, fostering more reliable imaging outcomes. One key takeaway is that inconsistencies in phantom design have historically hindered reproducibility across laboratories. This has prompted calls for more standardized approaches and phantom reporting within the broader biophotonics community, advocating for a consensus on best practices within smaller subfields. Addressing these gaps will not only solidify the foundations of optical technology, but also facilitate smoother transitions into clinical settings. The implications of this work extend beyond experimental protocols. The study notes that advancements in designing phantoms that accurately mimic various skin tones can help improve the accuracy of medical instruments like pulse oximeters, which have faced criticism for their differential performance across diverse populations. Given the recent scrutiny of device performance related to ethnic disparities in healthcare, this research has real-world applications that could ultimately enhance patient care. In conclusion, the authors stress that further enhancing the development and standardization of tissue phantoms is vital for bridging the gap between complex biological interactions and optical measurements. As the field progresses, it is clear that rigorous testing and validation with well-designed phantoms will be crucial for ensuring that innovative optical technologies are both reliable and equitable in their applications across diverse populations. The future of biophotonics is interconnected, and the standardization of tissue phantoms is a promising step toward fostering this evolution.
If you enjoyed this episode, please subscribe, leave us a review, and share it with your colleagues. Your support helps us shine a light on the latest in biophotonics research. Stay curious, and we'll see you next time.